Hi, my name is Muhammad Harbin Ali and my number metric is B122310656. So now, my group will talk about the subject Advanced Ethical Circuit assignment report BRT 13333. So now, my group will discuss for the transfer function with Bode. Okay, next. This is my group of member. We have Muhammad Hafiz bin Muhammad Rahizan and me, Muhammad Harbin Ali. Third, Ashraf Rafiq bin Muhammad Riza, and fourth, Muhammad Adam Iskandar bin Abdul Ghaffar. So now, I will talk about the introduction for the transfer function and Bode plot. For the transfer function H omega of a circuit is the frequency. H omega means the formula of the transfer function. This is calling for the transfer function, and of a circuit is the frequency dependent ratio of a phasor output Y omega. This is a formula of the n element voltage of current, calling the Y omega, to a phasor input X omega, source voltage or current. This is X omega, the calling for the source voltage or current. So this is a formula of the transfer function. H omega equal Y omega divide X omega. In the transfer function, we have four kind of possible transfer function. We have voltage gain, current gain, transfer impedance, and transfer admittance. So for the voltage gain, the formula is voltage output omega divide voltage input omega. Next, for the current gain, the formula is current output omega divide current input omega. Next, for the transfer impedance, the formula is voltage output omega divide current input omega. And lastly, for the transfer admittance, the formula is current output omega divide voltage input omega. Okay, next we go to the Bode plot. A Bode plot simply shows the magnitude and phase of a transfer function, so the two are directly related. The magnitude of the transfer function is shown on a logarithmic scale and the phase is shown in radians or degrees. The plot displays the magnitude in dB and phase in degrees of the system response as a function of frequency. So this is introduction for the Bode plot. So this is introduction for all introduction for the transfer function with Bode plot. So now we go to the question 1. So my group, we take question A and question H. So this is question A. We will discuss for the question A. So for the question A, we obtain to get the equation to get Bode plot, the magnitude of Bode plot, the phase Bode plot. So this is question 1. So the H omega equal 200 J omega divide J omega plus 2 J omega plus 10. So this is a calculation for the equation to get Bode plot. Right. So this first step and second step to the equation first. So now I will explain about the transfer function. So the formula for transfer function, the H omega equal 200 divide J omega plus 2 J omega plus 10. So for the equation, we must using the simple pole like the 1 omega, like the So for the equation, we must using the simple pole for 1 divide 1 plus J omega divide Z. So first, we must using the simple pole. So 200 divide and 2 we must put behind the J omega plus 2. So we must using the simple pole. Okay, so 1 plus J omega divide 2 and 10. We must put the 10 behind the J omega plus 10. So 10 1 plus J omega divide 10. Okay, so this is a first step. Okay, so this is using the simple point. Okay,
So now we must divide 200 and 2. So 200 divide 2, we must cut first the equation. Okay, sorry, first step we must cut the 200 divide 2. So now the equation will be 100 1 plus j omega divide 2 10 1 plus j omega divide 10. Okay, now next we must cut the 100 for divide the 10. So 100 divide 10 is 10. So the final answer for the transfer function is 10 divide 1 plus j omega divide 2 1 plus j omega divide 10. Okay, so this is for the transfer function equation. Okay, so thank you for me from. Okay, so this is a transfer function equation. Okay, thank you from me. Okay, I'm sorry for my mistake. So the true answer, I forgot to put the j omega from the 200 until last answer. So the final answer is 10 j omega divide 1 plus j omega divide 2 1 plus j omega divide 10. Okay, so that's all. Thank you.
Assalamualaikum and hello everyone, and also for our lecture. So my name is Muhammad Hafiz bin Muhammad Aizan. So now I will take over for my part is a magnitude block plot. So the first one, we will do a magnitude. Alright. So what is magnitude? So now we do an equation. HDB. So what is HDB in the block plot? In the graph, we assume this as a y axis. Okay. So now move on to the next. So this is, so equation is 20 log 10, and then we plus 20 log 10 open bracket j omega, and then we minus 20 log 10 1 plus j omega per 2, and then minus 20 log 1 plus j omega per 10. Alright, so this is a equation for the magnitude, but now we assume for the first one is constant. So why constant? Because from the equation, is 10 j omega 1 plus j omega per 2 and 1 plus j omega per 10. So this will be constant. Okay, So the next one is a j omega. We assume as number 2 will be the zero origin cut off. And then for the third one is, so we know that this is a simple pole from this equation. So we assume this is a simple pole. This will be a number 4. Simple pole also. Alright. So this equation for the magnitude SDB. So now I will show how to plot a graph. Now I will continue for the graph. So this is a graph that I have drawn. So now we want to know how to plot, how to know this graph. So the first one is, if you can see from this side, this is from this equation. So in this part we just draw 20 log 10 over 10. Okay, so these are the first, as we know. So the second one from the equation, this one for j omega. So j omega adalah zero origin. So this is a cut off. So from the cut off, we know this will be cut off. Alright. So we just, so this will be zero origin, will be plus 20 dB. Alright. So that will be second. And then for the third, from this also equation, from simple pole, this part will be j omega 2. So j omega 2 from this one. Or before that, before we know this type of x-axis, we just plot, we just draw 2 and 10. So we start from the 2 with 0.2, 2, 20 and 200. For the 10, we start from 0.1, 1, 10 and 100. So that's we know how to put the number of x-axis. So the effort 2. So next, so the 2 will be number 3. Number 3 will be negative 20 dB dig. Alright. For the 4, 10 to 100, the for titik silangan. So this will be 4. Same, maybe 20 dB maker. Alright. So that's how we know how to know the graph from the equation that we know to use. So this part will be silangan dia. Okay, so that's all from me.
Okay, Assalamualaikum. My name is Ashraf Rafiq bin Muhammad Rizal. My matric number B1223105885. Okay, for my part, I will explain about the phase graph. Okay, first of all, I will take the equation from the early, which is in equation that have been simplified form, which is 10j omega over 1 plus j omega over 2 multiplied by 1 plus j omega over 10. So here is the equation that in simply form. Okay, now for the phase graph, first of all, we have to derive in the phase graph equation, which is equal to, in phase graph, equal to the arctangent multiplied by 10 omega over 0. Okay, for the first equation, we take from the first up here. Why we are divide by 0? Because in the first equation is we doesn't have a denominator, so just assume divide by 0. Okay, next part, in the bottom one, which is the denominator. Next part is because of the next part is dividation, so the equation next will be subtraction. So minus arctangent multiplied by omega over 2 divided by 2 omega divided by 1, and then next is minus arctangent multiplied by omega over 10 divided by 1. So here is the first step of phase graph equation. So next part is we simplify the equation, which is we will get arctangent 10 over 10 divided by 0 will be infinity, and then next part is negative tangent will be omega over 2, and next is negative arctangent will be omega over 10. Okay, here is the second step of the equation. So for the last step is arctangent infinite equal to the 90 degree, and after that we just copy all the next equation, which is arctangent omega over 2 minus arctangent omega over 10. Okay, so here is the equation for our phase graph. Okay, for the next part. Okay, now for the next part, we will go through to the graph. So we'll go to the equation first. So this is the part 1. We will go to the graph. So this is part 2. Oh, sorry. This is part 2, and this is part 3. Okay, so first of all, we go to the graph. At graph, as we will see before this, so first we have to draw imaginary line for 90 degree. Which is 90 degree, we have to draw a straight line, imaginary line, which is imaginary line is dash line. Okay, so so then we have to draw the line at the 90 degree straight line, and then I have to change it. I have to change it to the dash because it is a imaginary part. So we rename here first in our face shift now. I think it's too long. Wait, so here is our first part. That is 90 degree. Okay, for the second part, you see here is a arctangent omega 2. So for arctangent omega 2, we have to plot start from the 2, set from 0.2. Yes, start from 0.2. Okay, at 0.2, we will start with a 0. So we plot the 0 and jump to 1 decade, which is 2, and 1 decade will drop 45 degree. So at point 2, x value of 2 will plot x drop at 45 degree. So here, and for the next is 20, also at drop negative 45 degree. So at here will be a negative 90 because of negative 45 degree plus negative 45 degrees. So will be a negative 90 degree. And at the value of 200, the value will be constant because the maximum of value of the phase value is 90 degree. Okay, for the next part, before we go through to the next part, I will draw the line to connect all the plot. Like that, and the line has to be dash, and we change the color to the straight line. Okay, so that I will rename it to the second part, which is negative arctangent omega over 2 for this part. Okay, next part, we will go to the next part is we go to the equation, which is arctangent omega over 10. So omega over 10, we will start with the value of 1. So value of 1, we will start with same with the early, which is start with 0, and the next point at the value at 10. So the value will drop 45 degree. So the plot will be at here, somewhere at here, and then for the next part is 100. So 100 will drop another 45 degree from before, which is 90 degree. So the next we'll also do the same things, which is we'll draw a straight line to connect all the plot. Okay, like that, and then we'll make the dash line because of this is an imaginary line before we draw the real face graph. Okay, so I will rename it to this is the part 3 of our equation. So part 3, which is a negative arctangent omega by 10. Oh, I think have to write it beside the arctangent, omega over 10. So for the next part is we will draw the real graph. The real one is which is start from the 90 degree. So for the next part, I will go to the color with color yellow or purple. So the next part is from the So I will go to first we start with the 90 degree, and the line will touch at the first value line at here, and then we will continue at 10. Here, and then the second part is connect to here, and the last part is we will connect to the 100. Okay, like that. So here for the first is I will rename it to the here is here we will drop negative 45 degree per decade, and at here the drop is negative 90 degree per decade. And for the last part at the bottom one is negative 45 degree per decade. Okay, so the purple line is the face graph. Okay, so that's all from me for the face graph. Thank you.
Assalamualaikum. Hello, my name is Muhammad Adam Iskandar bin Ghaffar. Today I'm going to explain about the Bode plot. So this is the question H. So the first thing that we know, the y-axis is in H decibel, and the x-axis is in omega. So from 0 to 100 omega, it remain constant in 40 Hz decibel, which is 0 decibel per decade. And the second one is 100 omega to 1000 omega. It beginning to decrease, which is the value is negative 20 decibel per decade. So in 1K, the third one, it remain constant again, which is 0 decibel per decade. For the calculation, the first one we can use 40 equals to 20 log K. The 40 we can get from the graph, which is from y-axis for 40 Hz decibel. So in this equation, we can get the value of K is 100. Second is simple pole negative. Means in simple pole negative, we should use the decreasing part of the graph, which is 100 omega to 1000, and we can use negative 20 decibel per decade at omega 100. So the equation is j omega over 100 plus 1 and power of negative 1. And the third one is simple 0 positive. 0 decibel per decade at omega 1000. So the equation is j omega over 1000 plus 1. So eventually we can get the equation 100 plus j omega over 1000 divided by 1 plus j omega over 100.
Okay, so now I will talk about the conclusion. The transfer function of the system or filter is shown in the Bode plot at the end, providing a comprehensive understanding of the system frequency domain. The system's phase at various frequencies as well as its magnitude can both be used to characterize this response. This magnitude and phase computations give a clearer picture of the system's functionality efficiency across a range of input signal frequency. So that's all for my groups. Thank you.